Given everything that we know now, let's review our current, agreed upon, and denormalized data schema design.
I've made some generic JSON to map out what we've discussed for the final data design, and I went ahead and I included it in the instructor notes. Be careful about not overwriting your database with it. You can always make a new Firebase app backend if necessary. To frame all of this, let's think about the screens that we're interested in. The two that we've been talking about a lot are the shopping list fragment and the active list detail screen. And remember, the goal is to allow users to be able to create lists and share lists, and then they should only see the lists that they either own or are shared on. Okay, so I'm going to load up this JSON and open up our backend and sort of walk you through what's going on. Here are our top level nodes. Following our discussion of two-way mapping between users and the list they own, I think the best way to handle this sharing functionality is to have a list of shopping lists for each user. Here, let me show you. We're going to have this node here called user lists, and this will contain, for each user, a list of the lists that they have access to. That means if Kaguri, JP, myself, and Walter are all in the shopping list ++ system, then there would be a separate list of shopping lists for each of us. And again, these would be the lists that we either own or are shared with us. So in this case, Walter has one list shared with him. And if he were to create or be shared on with another list, that would also appear here. And this is actually pretty much all of the information that we need for the shopping list fragment. You could go ahead and attach your Firebase list adapter here at the encoded email address of the user who's logged in. So if Walter was the one logged in, then we could attach a listener here, and it would very easily display the list that he owns. Since we got the shopping list fragment figured out, let's think about the active list detail screen. For the list detail screen, we'll need the list information, which we can grab here from the list of user lists. And we can get that because at that point we should have the encoded email of the user and the push ID of the list. And that gives us enough information to drill down to the email and then the push ID to get that list information. And from here we can get things like the user shopping on the list and the list name. And then as we've already been doing, we denormalized and had the shopping list items up here. And we can use that same shopping list push ID to get the shopping list items for the list, as we've been doing. Okay, so that explains the use of both the user list and the shopping list items. Now at this point, you're probably thinking that this design has a non-trivial amount of data copying. Here, each of us has our list of lists in user lists. And if we each make 4 different lists and we own them, this is what it would look like. But let's say that Kagure decides that she wants to share her Book Club Snacks list with all of us. What this would then do is add a copy of Book Club Snacks to each of our lists. A total of 3 more copies. Now this design here makes reading from the database lightning fast. We never have to search through a list of all shopping lists, or pull down any extra data. But you're probably thinking that there must be some downside to all of this copying. Well, there is. Whenever you change anything about the shopping list, such as if Kagure changed the list name to Book Club Snacks, you need to do this for all copies of the shopping list. So now, instead of changing something in just one place, you need to change it in 4 different places. And more importantly, when you update a list, you need a way to know quickly if there are other copies of that same list in the database without any extra sorting or filtering. For example, if you're just looking at this wilderness survival list here, you have no way to know whether it's been shared with other users. And for that, we have a node called shared with. Let's take a look at it in the database. So here's shared with. This node is kind of like shopping list items. For every list that is shared, you will have an entry in shared with, and the key of that node will be the list push ID. Inside of that node will be a list of users that shopping list has been shared with. So going back to our book club example, when you want to update the value of a list, such as the list name, you have one place where you can look up all the users that the list is shared with. This allows you to construct the various URLs that you'll need to get to the user list in the database. Because now you have access to everybody's encoded email, you have both parts, the encoded email and the push ID that you need to get to a specific list. Okay, so at this point we've talked about shared with, shopping list items, and user lists. We're going to keep around our list of users, which will just have all of the users that are in our app. And this is functioning as it did before. We'll also make some user friends lists, but I'll talk more about that when we go into implementing those screens. Okay, so if you want to take a look at this database structure yourself, you can load up the JSON file in the instructor notes. Once you have a handle on what's changed and what's sort of going on here, we'll start the refactor from the huge list of shopping lists that's currently stored in the active list node to this new user lists-centric organization that I've just described.